In this video, we'll learn how to solve this absolute value equation and how to write up our work. In a previous video, we discussed the general strategy for solving an equation of this form. Absolute value of a linear expression equals a number. Take a closer look at the absolute value equation we have been given to solve. Do you see how we may algebraically manipulate this given equation to make it look like one discussed in a previous video? By algebraic manipulation, I mean adding or subtracting the same number to both sides of the equation, multiplying both sides of the equation by the same number, or dividing both sides of the equation by the same non-zero number. Such actions, as you must know by now, do not change the solution set of the given equation. Pause the video and you now algebraically manipulate the given equation to this form. Absolute value of a linear expression equals a number. Okay, here we go. Adding 47 to both sides, we get this step. Dividing both sides by 3, we get this step. The given equation and this equation obtained by the algebraic manipulations are equivalent. That means the solution set of these two equations are exactly the same. So, our task of solving the given equation is same as the task of solving this equation, whose form should be familiar to you by now. Indeed, in a previous video, we discussed how to solve such equations. Pause the video now and complete this problem by solving this equation. Show all steps in the manner discussed in a previous video, including an opening sentence and a conclusion. When you're done, I'll show you the rest of the work for this problem. Pause the video as needed to check your work. Notice that when we write these two linear equations, we should not have absolute value vertical bars anymore. If you find yourself making such mistakes, watch the previous videos on this topic to understand the logic behind this approach. Finally, be sure to substitute these values into the original absolute value equation and make sure each one indeed satisfies the equation. I'll leave that for you as an easy exercise. A few words of caution. Some students look at this equation that we just now solved and incorrectly conclude that the equation has no solution since they see an absolute value expression here and a negative number on this side. To understand why that logic is flawed, you must pay close attention to the definition of absolute value. You will recall from the definition, we can only conclude that absolute value of a number cannot be negative. And so in this case, we can only deduce that this absolute value expression in the equation is non-negative. When we multiply this non-negative expression by 3 and then subtract this negative number, we can certainly get a negative number. In essence, a presence of a negative number on the right in this kind of scenario simply means further inquiry is in order. So the way to approach such equations is to manipulate the equation and turn it into the form that we know how to solve. That's the approach we took earlier in this video. Here's another problem for you to try, where you must first algebraically manipulate the given equation to make it look like this. Absolute value of a linear expression equals a number. A few more words of caution. Firstly, note that we cannot add the 1 and 6 here. Remember, x is a real number, and so this absolute value expression is a real number. By order of operations, this real number must be multiplied by 6 first before this 1 is added to it. Another thing to be careful about is the following. It would be incorrect at this time to split this absolute value equation into the following two linear equations. To understand why that logic is flawed, you must recall a discussion from a previous video where we used this slide. When c is positive, we can pursue this approach only when we have an absolute value equation of this form. Absolute value of a linear expression equals a number. Otherwise, we need to first algebraically manipulate the given equation to make it look like this familiar one. Thank you for joining me today. See you soon in another video.